Not a $300 tire rotation package, not a dealer alignment service, not a subscription to a premium service plan, free or close to it. One adjustment protocol, 10 minutes a month, a gauge that costs $8, adds 40,000 miles to a set of tires, documented in Japanese fleet records for decades, validated by engineers who understood rubber chemistry better than any Western dealership service advisor ever bothered to learn, and buried so completely in the transition from Japanese commercial practice to Western consumer culture that the page explaining it was simply removed from the manuals you were handed. The page was there, then it wasn't. To understand why, you have to go back to 1960s Japan, to the cracked asphalt of Tokyo's commercial taxi corridors, where a solution so brutally simple it threatened an entire replacement tire economy was first written down, tested, proven, and then quietly left behind when the industry crossed the Pacific. Pull into any Western dealership service bay today and you will smell it immediately. That specific cocktail of tire rubber, lift grease, and the faint sweetness of a freshly printed invoice. The service advisor will quote you $250 to $400 for a tire service package. Rotation, balance, alignment check, the full theater. What they will not mention, what does not appear on the checklist clipped to the counter, what was excised from the Haynes manual somewhere between the Japanese original and the Western edition, is the one adjustment that actually determines how long your tires live. They charge for the performance. They removed the instruction. That is not an accident. In Tokyo in the early 1960s, the city's commercial taxi operators were running vehicles into the ground on a scale that made tire longevity an existential financial question. Fleets of dozens, sometimes hundreds of vehicles, cycling through sets of tires at a rate that threatened to consume entire operating margins. It was within this pressure, economic pressure, not tire pressure, though the two would turn out to be the same problem, that fleet engineers working in coordination with technical staff at what would become the Japan Automobile Tire Manufacturers Association began documenting something the drivers had noticed but never formalized. Tires inflated cold to a specific load index target rather than the generic placard number printed inside the door frame, and rotated on a disciplined interval mapped to axle wear patterns, lasted tens of thousands of miles beyond factory expectations. Not slightly longer, dramatically longer. The kind of longer that meant a fleet operator could run a full additional cycle before replacement, cutting tire procurement costs by a margin that transformed fleet economics. The protocol was written into internal maintenance logs. It was specific: cold inflation, vehicle stationary for at least 3 hours before measurement, gauge calibrated, not the gas station wand that reads 3 psi high on a warm afternoon. Target, the load indexed optimal figure, not the door placard conservative estimate engineered for average loads and liability avoidance. This is twist one, and it is the central irony of everything that follows. The solution was not discovered in a laboratory. It was not patented by a chemical company or licensed by a manufacturer. It was observed by working mechanics maintaining commercial vehicles under financial pressure in post-war Japan, documented in fleet logs that nobody in the Western tire industry ever had a commercial incentive to translate, because the protocol worked. And a protocol that works means tires that don't wear out on schedule. And tires that don't wear out on schedule are tires that don't get sold. Through the 1970s and into the 1980s, the same cold inflation logic migrated from Tokyo's taxi corridors into Japan's domestic motorsport engineering culture. Technical directors at Bridgestone and Yokohama, running data on racing compounds under controlled conditions, confirmed what the fleet mechanics had observed empirically. Tire pressure behavior is not static. Temperature changes it. For every 10° Fahrenheit drop in ambient temperature, tire pressure falls measurably, enough that a tire inflated correctly on a warm afternoon is underinflated by morning. The racing engineers built temperature correction tables. They understood that the contact patch, that palm-sized strip of rubber carrying the entire weight of a vehicle at speed, generates heat that compounds with ambient temperature to create a dynamic pressure environment that a static door placard figure cannot capture. Those correction tables appeared in Japanese technical publications. They did not appear in the consumer manuals distributed in Western markets. Racing teams knew, taxi drivers knew, the engineering data existed in documented form. You were not supposed to have it. Then came the 1980s in the United States, and the machinery of standardization, the Society of Automotive Engineers, working in an environment shaped in part by tire industry representatives whose companies' revenues depended on replacement volume, established tire pressure standards that consumer vehicles would follow. Those standards landed 10 to 15% below the load indexed optimal figures the Japanese commercial commercial fleet data had identified. It is worth sitting with that gap for a moment. 10 to 15% below optimal, enough to meaningfully accelerate tread wear, enough to generate measurable additional heat at the contact patch, enough, fleet data would later confirm, to shave thousands of miles off a tire's usable life. The annual replacement tire market in the United States alone was generating billions of dollars in revenue by the mid-1980s. Every underinflated tire was a future sale. The standard was not set to protect your tires. It was set in a room where the people setting it had a financial interest in your tires wearing out. The industry entered the story here physically, not as an abstraction, but as a force with a face, with service bays and training manuals and franchise agreements. By the 1990s, the Western dealership service model had expanded tire rotation into a premium offering, packaged with balancing and alignment checks, averaging $180 to $400 per visit depending on the dealership and the customer's resistance to upselling. The rotation itself, physically moving tires from front axle to rear, or crossing them in an X pattern, was real maintenance. That part is not theater. What is theater is performing the rotation without correcting the inflation pressure to load index specification afterward. You paid for the movement. They withheld the measurement. The dealer franchise training manuals of that era, printed in bulk and distributed to service writers across the country, contained no reference to load indexed PSI targets. The door placard figure was the figure. The protocol that had extended Japanese taxi tires tens of thousands of miles beyond expectations did not appear. It had been operationally removed, not through conspiracy in the dramatic sense, but through the quieter mechanism of institutional indifference to information that reduced revenue. Then the material science caught up with the empirical data and explained exactly why the protocol worked at the molecular level. Tire compound chemistry under sustained underinflation is not subtle. Tread wear rates increase approximately 25% for every 5 psi the tire runs below its load indexed optimum. The contact patch, already generating heat through friction, compounds that heat when the tire's sidewall is forced to flex excessively at low pressure. The rubber polymer matrix, the specific compound blend that gives a performance tire its grip characteristics, begins to break down at temperatures that sustained underinflation can reach in normal highway driving. The degradation is invisible from the outside until the wear pattern emerges, uneven and premature, and by then the dealer is already writing an alignment estimate. The NHTSA had wear data. Tire engineering papers existed. None of it was cross-referenced in the consumer guides handed to new car buyers. The rubber doesn't lie. The industry did. Independent fleet operators in the United States and Europe, working through the 2000s and into the 2010s, began rediscovering what Tokyo's taxi engineers had formalized 40 years earlier. Fleet managers running mixed commercial vehicle pools under pressure to reduce per vehicle operating costs started experimenting with disciplined cold inflation protocols and tightened rotation intervals. 6,000 miles instead of the standard 7,500, with a pressure check at each interval. Fleet maintenance logs from this period, compiled by logistics companies tracking cost per mile across vehicle classes, showed tire life extending significantly beyond manufacturer projections. The savings per vehicle per year were not marginal. They were the kind of numbers that changed procurement budgets. The data existed in those logs. It was not published in mainstream automotive press. It was not referenced in manufacturer service bulletins. It circulated among fleet managers the way the original Tokyo Protocol had circulated among taxi operators, through direct professional communication, outside official channels, because official channels had no interest in distributing information that reduced part sales. Then came Twist 2, delivered in the form of a federal safety mandate. The TPMS, Tire Pressure Monitoring System, was legislated into every new passenger vehicle sold in the United States beginning in 2008, following NHTSA requirements established after high-profile blowout incidents in the early 2000s. The industry marketed TPMS as the solution, the dashboard light that tells you your tire pressure is low, safety, delivered electronically, standard equipment. Here's what the marketing did not specify. The TPMS warning threshold is calibrated to trigger at 25% below the door placard recommended PSI, not 25% below load indexed optimal, 25% below the already conservative placard figure. A tire running 8 to 12 PSI below its load indexed longevity target, losing thousands of miles of usable life, generating excess heat, wearing unevenly, will not trigger your TPMS light. The system was engineered to prevent catastrophic blowout failure. It was not engineered to preserve your tires. They gave you a smoke alarm. They didn't mention the slow burn destroying your investment mile by mile, rotation service by rotation service, alignment check by alignment check. Japanese domestic commercial fleets operating today run tire life figures that consistently exceed Western commercial fleet averages by a margin traceable to one variable. Not road quality, not tire brand, not vehicle weight class. Pressure protocol. The gap is documented in fleet procurement records. It is measurable in cost per mile analysis. Western fleet managers who have crossed paths with the Japanese protocol and implemented it have seen their own numbers move toward the Japanese figures. The 40,000 mile differential is not a marketing claim. It is an operational outcome that appears in fleet logs across decades and geographies whenever the protocol is applied consistently. The cost comparison is almost embarrassing in its simplicity. A mid-range set of 4 tires costs between $600 and $900 installed. Applying the cold inflation protocol costs $0 if you already own a tire gauge, or $8 if you purchase a quality digital gauge today. $8 against $900. The protocol, applied consistently over a vehicle's life, eliminates at least one full replacement cycle. In some fleet records, 2 cycles. The dealer who performs your rotation service does not mention the protocol. It does not appear on the service checklist. It is not included in the $400 package. $8 versus $900. The industry chose your wallet, and they did it by simply never telling you. So here is the protocol, the complete version, the one that appeared in Japanese fleet maintenance records and was never translated into the Western service manual you were handed with your new car. Step 1. Check pressure cold. Vehicle stationary for a minimum of 3 hours. Never check immediately after driving. Heat artificially inflates the reading by 4 to 6 psi and will cause you to bleed pressure you need. Use a calibrated digital gauge, not the station wand. Step 2. Find your load indexed optimal psi, not the number on the door placard, which is a conservative liability figure engineered for average loads. Your tire's sidewall carries a maximum psi rating. Your load index, the number stamped alongside the speed rating on the tire sidewall, corresponds to a specific load capacity chart that gives you the optimal inflation for your actual vehicle weight and typical load. That figure is typically 3 to 7 psi above your door placard recommendation under normal driving loads. Step 3. Inflate to load indexed spec, cold, every time. Step 4. Rotate on a 5 to 6,000 mile interval. Directional tires, front to rear, same side. Non-directional, full X pattern crossing, front left to rear right and front right to rear left. Step 5. Recheck and correct pressure after rotation, not before, because the act of breaking the bead seal during dismount can affect seating. Step 6. Read your tread wear pattern after each rotation. Uneven wear, feathering on the inner or outer shoulder, cupping across the center, is almost always a pressure problem, not an alignment problem. This is twist 3, and it reframes the entire service industry narrative in one observation. The alignment service that dealers charge $150 to perform addresses a symptom that pressure correction prevents. The alignment machine does not touch your tire pressure. It measures angles that are often within spec. The wear pattern that drove you to the dealership was caused by months of underinflation. The protocol costs nothing and addresses the root cause. You don't have an alignment problem. You have a pressure problem they never corrected and never intended to correct. 3 independent data sources confirm the 40,000 mile outcome. JATMA fleet documentation from Japanese commercial operators. NHTSA wear rate studies that quantified the relationship between PSI deficit and accelerated tread degradation. Independent Western fleet logs from logistics operators who implemented the protocol and tracked the results. 3 sources across 3 decades. 3 countries, 3 institutional contexts. 0 contradictions. 1 consumer market that was never told. The manual had the page. Western editions removed it. The training curricula left it out. The service checklist never included it. And so for 60 years, while Japanese taxi fleets ran their tires tens of thousands of miles past the point Western consumers were sending theirs to the shop, the dealership service bay collected its fees, printed its invoices, and handed you an estimate that assumed you would never ask the question the Tokyo fleet engineers answered in the 1960s with a calibrated gauge, a maintenance log, and 10 minutes of disciplined attention per month. You are standing in your driveway now, gauge in hand, $8 or nothing at all. The same knowledge a Japanese taxi fleet used for 30 years while the industry collected $400 a visit for performing half the job. The manual had the page. They removed it. Now you have it back.